Hello, let's talk about the complex numbers today. So here we go. Complex numbers. So what actually is a complex number? Complex number is a combination of actually imaginary number and a real number. So real number is any number that can be plotted in a number line. So this is a number line, 0 in between, and it can be extended up to infinity towards both ends. So now this is 1, this is 2, this is 3, so this is -1, -2, and this is -3, and it continues like this in both the directions. So now let me make you extra sure that complex numbers cannot be plotted in the number line, due to which you cannot compare complex number. For example, if you ask me -7i and 7i, which one is greater? I cannot tell. Not only me, anyone cannot tell, because see, since it cannot be plotted in the number line, we cannot compare. And you know what is the basic rule for comparison? Any number that lies at the right side is greater. For example, 2 is greater than 1. You know why? Because 2 is on the more right in the number line of 1. Similarly, why -1 is greater than -3? Because -3 lies on the left side of the -1. So this is on the right side, which means -1 is greater than -3. Now, we cannot say this because we haven't even plotted this, and we know there is no any provision to plot imaginary numbers. Now, let's start from I. What actually is I? I is square root of -1. And now let's have a look at 4 or 5 properties of I. So it's actually a single property. Let's call it 5. So I to the power 3, I to the power 4, and I to the power 5. So I to the power 2 means I times I, which equals -1 root times -1 root, which will be -1. Similarly, I times I equals -1 times -1 times, let's say I. So it will boil down to -I. And again, for this part, remember this is really important, because most of the tricks that you'll be using in the complex number will be from this I to the power 4 logic. So that's why it is I to the power 2 times I to the power 2 equals -1 times -1, which is +1. And now for any number that you'll be finding, let's say power of I, for any number that's the power of I, just condense it down in terms of power of 4. So I to the power 4 times I, which means I. Similarly, I to the power 6 equals I to the power 4 times I to the power 2, which is I to the power 2 equals -1, because we know I to the power 4 is +1. So let's have a look at one example. Let's say I to the power 393. So let's say I to the power n, and this is just our assumption. So now 393 divided by 4. Okay, so here's the basic theory. Divide n by 4 and break it down into quotient and remainder part. So ignore the quotient, because any quotient that you'll be getting from this process will be in terms of I to the power 4, which means it will be giving us 1. So we don't need to worry about 1, and r means remainder, and we need to take care of remainder only. So let's look at here. 4, so it goes 9, so which is 36, and again 3 it comes here, and 3 and 4 is 32, and 1, this is remainder. So let's have a look at here. Dividend equals to divisor times quotient plus remainder. So here 393 is a dividend and 4 is a divisor times 98 is a quotient plus 1 is a remainder. So now it boils down to this. I to the power 393 can be written as I to the power 4, and how many of them? 98. So times I, because 1 is a remainder. So if it were 92, then it would be 2. So it will be 1, because we know from here. Let's have a look at here. Okay, from here I to the power 4 means 1 to the power 98 times I. So this is I. That's why I to the power 393 will be I itself. So Don't forget this trick. So just divide it by 4, and you can use this trick in another problem as well, the problem related to let's say exponent of 3 and 2 and others as well. So okay, if you were asked a question like that, 3 to the power 393 equals what? So this can be a real trick, because even calculators, they surrender in the problems like that. So here's the trick: 3 to the power 1, 3 to the power 2, and 3 to the power 3, 3 to the power 4, 3 to the power 5. So here's the trick. Let's analyze the pattern. It will be 3, it will be 9, and it will be 27. It's 81, and I don't know what's in here. I don't know what's the number, but I can safely say that it is 3 in the end, and 3 to the power 6 will be, it will be 9 in the end, it will be 7, and again 1. So the pattern continues like this. So now what will be the last digit of a number that is produced by calculating 3 to the power 393? So if you have to analyze it, so again the same trick applies, like 393. If we divide it, you will get 98 here and 1 as a remainder. Now see, since it has 1 in the end, any multiplication that 1 does with 1 will be 1. So that's why 3 to the power 392 times 3 to the power 1 would be 3 to the power 393. So at the end, we're just calculating the last digit, not the whole thing. So this will produce 1 in the end, because it's divisible by 4, and it boils down to this actually. And now 3, there will be 3. So that's why the last digit of 3 to the power 393 would be 3. You can use concept right here as well. Alright, so let's have a look at the addition, subtraction, multiplication, and division of the complex number. So a plus bi, this is a complex number. Let's say this is a, and for b, let's say c plus di. For addition and subtraction, okay, you can treat this I as ordinary variables. Let's say a plus bx and c plus dx. It will be the same thing, because you'll be analyzing this with this. Sorry, you'll be calculating these two things and these two things. So these are real part. Now this is the coefficient of I, this is the coefficient of I as well. So while adding and subtracting, if you were given to subtract this, just do this: a minus c, and now again plus b minus d, and I in the end. If you are given to add these two, a plus c, this will be the real term, and plus, though these are the real, but since they are the coefficient of I, we have to do them separately, like b plus d I. So you get the result like this. And now there's another thing you need to understand here. So product of any complex number to its conjugate is real number. So don't forget this. For example, let's say 2 plus 3i, and what is its conjugate? 2 minus 3i. Let's multiply it. You can use ordinary algebraic multiplication, like 2 times 2 minus 2 times 3i, again plus 3i times 2 minus 3i times 3i. So this will cancel out, and we get 4 minus 9 times I equals minus 1. So we'll get minus 1 root minus 1 squared. So this will be 4 plus 9 equals 13. So we get the real number again. Now for division part, if you have to divide two complex numbers, let's say 2 plus 3i divided by 1 plus 2i. So in this case, don't worry, just do this: 2 plus 3i, and in denominator 1 plus 2i. Now take care of it. Forget this, just consider this one, and multiply both numerator and denominator by conjugate of the denominator. So 1 minus 2i and 1 minus 2i. Just simplify it, and you will get the real number in the denominator and you will get the complex number here, and use the term separate method, and that's the division of complex number by another complex number. So only these concepts they will be tested on the SAT. So if you are clear with these concepts, so you don't need to worry about anything else. So let's revise it. You cannot compare complex number because they cannot be plotted in the number line, and in number line whichever number is on the right side is the greater than the number whichever in the left side. And don't forget the rules of this I equals root over negative I and I square equals negative 1, I cube equals to negative I4 equals to 1. It's a very crucial relation, and you can calculate it accordingly. And if you have to find the value of I to the power some number, just follow this rule, divide it by 4, ignore the quotient. You can ignore it altogether because it will be giving us 1, positive 1, and then just consider the remainder part and break it down like this. Again, division equals to divisor times quotient plus remainder. We know this from the very basic mathematics, and we solved it. And this pattern can be applied to find the last number of any exponent, like 3 to the power 393, 2 to the power any sum. Just divide it, look at the pattern, and we can calculate it. And for the operation related to complex number, if you have to add two complex number, add real part, add coefficient separately, and you can treat it as a as an ordinary algebraic variable as well. So for the product part, product is also like same, but just use the ordinary algebraic multiplication. And don't forget one thing, that the product of conjugate of an imaginary number with the imaginary number would be a real number. So we get it here. And again, for division, if you have to divide one complex number with another complex number, write it in the form of numerator and denominator. We often do this, and then find the like multiply both numerators and denominators with the conjugate of the denominator, and we get the real part in the denominator and complex part in the numerator. And for the ordinary division, let's say division of a complex number with a real number, you don't need to worry about anything. Like, let's say like this: a plus bi divided by c. A plus bi divided by c. Use the term separate method and you would get a by c plus b by ci. So this is the division of complex number with real number. So you don't need to worry about this particular thing. So thank you for watching. Please subscribe.